the Wheatstone network, let's check. The ratio of these two arms, we check it, 4/8 is not equal to 2/6, you see. The ratio of these two arms is 1/3. The ratio of these two arms, 4/8, is not equal to 2/6, no? So therefore, potential X not equal to Y. In fact, a current flows through this branch. Then, how to calculate current in all branch? How to calculate the current in all branch? Means current in this branch, or current in any branch, how to determine. Here I'm going to introduce a nodal analysis. The algebraic sum of currents at a given junction should be 0. Where we are seeing the junctions, next question comes. Where sir, I'm not seeing any junction. Is this a junction or a node? Better you call. Are you seeing junction? What do you mean by junction? Where more than 2 branches meet, it is called as a junction. How you define junction? It's a point where more than 2 branches meet. Now, what do you mean by branch? I think there's a branch, no? I can call this is, you see, like this is one branch. This is one branch, and this is one branch. Are you looking at this? There are more than 3 branches are meeting at a point. So therefore, this X will become a junction, or I'll call it as a node. So X and Y, I'm going to give a specific names. Nodes. No, at a junction, algebraic sum of current should be equal to 0. There's a thing. So like this, I'll identify the node. So let me define potential. This is a cell of EMF 20 volt. The potential difference across that should be equal to EMF 20 volt. So let me define this as 20 volt potential. Then the other one should be 0 volt. So this will be 0 volt. Like this, I'll define the potential. Then let the potential of these nodes, let it be X and Y. This X and Y are potentials. If you want, you can write Vx. I'm directly writing as what is the potential at this junction? X. What is the potential of this junction? Y. I'll call than junction, I'll call node. Junction or node, both are same. We can also so what is the potential at this node X? Let it be X. At node Y, let it be Y. Then algebraic sum of currents entering a junction. So X minus 20 by 4 plus X minus 0 by 8, X minus Y by 5 should be equal to 0 from the KCL. Similarly for this, Y minus 20 by 2, Y minus X by 5, Y minus 0 by 6. 2 equations, 2 unknown. X and Y are unknowns. I'll solve them. Then I'll end up with X equal to 13.81 volt. What is value of Y? Potential at this node, 14.72 volt. Once I know those potentials, X and Y, I can easily predict what is the current in this branch. What is I1? I1 will be 20 minus, okay, let's do one thing. Let's come to the, let me define. So I know potential at this point, I know potential here. So can we predict I1? Let I1 be the current in this branch, 4 ohm. Let I2 be the current in this branch, 2 ohm. Then let me assume a current I3 here. Then here I3 and I1 will get added up. So this will be I1 plus I3. Then a current I2 enters this branch, I3 leaves. Then the resultant current, how much it should be here? I2 minus I3. Then these two will add up. I1 plus I3, I2 minus I3. The resultant will be I1 plus I2. How much of current leaves positive terminal? That much of current should enter negative terminal, because charge should be conserved. No? Charge of a cell must be conserved. Because what is a current? Current is nothing but rate of flow of charge. Okay, like this we divide the current. Now these currents are to be determined. Okay, how to calculate this current I1? 20 minus X by 4. Because I know potential here, no? I know potential difference across this 4 ohm, 20 minus x by 4. This will give I1. 20 minus y will give 2 ohm resistance. Similarly, here Vy minus 0 will give current in this branch. Vx minus 0 will give current in this branch. What was my question? To determine the current in all the branches. Yes, after getting I1 and I2, that I1 and I2 as to applying KCL as to enter here. That I1 and I2 should enter here. Then this I1, I2, I replace this walls, this 5 resistors by an equivalent resistance. I'll call that as RAB. The net resistance as seen by the cell. After getting I1 and I2, I can calculate the net resistance as seen by this cell. So I'll get RAB. So now are these two are in series? No, they are not in series. Are these two are in series? No. Are they in parallel? No, they are not series, not parallel. So what is the only alternative? No, a methods of like this. What is the nodal analysis? So what is the primary important thing? Like you have to identify the nodes. Then you should define the potentials at various nodes.